information on the exact time of next Tuesday?
Oh yes, for your information, note that our meeting for the department is 11:30 to 12:30, not noon slot. 11:30 to 12:30 on Tuesday of next week, and we'll be meeting in this room, and Dr. Susan Allen will be really discussing with us, not simply talking to us, but discussing with us issues that we have for the department.
I know everybody's ready for the end of the semester, right? One more week. Now, there's plenty of food. Feel free to take a plate with you, snack home, it's a sandwich to go. I hope you like the pork and the beef too. It's interesting because depending on which state you live in, when you ask for barbecue, you either get pork or beef. When I lived in Texas, every time you go out for a barbecue sandwich, if you didn't say you got beef. Here in Arkansas, a lot of places that are barbecue don't even have beef. They only make pork. But both are equally good. What we're going to talk about today is, I've always been interested in IT curriculum, and we call it CIT, MIS, data processing back when we started in 1987. But we as faculty members have basically three roles here on campus. One is teaching, one is research, and one is service. In my opinion, now much of what I tell you is going to be my opinion. In my opinion, our bread and butter is teaching. I mean, that's what pays the bills. That's the main purpose that we're here for. We're here to help you become better prepared for the workplace so that you can get the right kind of job. And the way we do that is through a proper curriculum. We don't want to be teaching you something that is 10 years old. We don't even want to teach you in our department anything that's 5 years old. We want to teach you what is as current as possible. And we know that we don't always have the funding, we don't always have the equipment, we don't always have the software to do cutting edge, but we try to get there as soon as possible. What I did back in 1987, and it's hard to believe that's 20 years ago, but in 1987, I was interested in IT curriculum. I did some studies, we'll look at a couple of results, and then I did it again in 92, I did it again in 97, I'm currently doing it again in 2006. So actually I'm looking at what's happened to IT over 20 years. Now this is quite a large study, and I tried to condense it down to about 30 or 40 minutes so you won't be bored and senseless. So it's basically an overview, but some things I find interesting. For you as students, you also might find how things have changed, what industry is asking of us when we get out of the workplace, or review when you get out of the workplace. First of all, why is it important to change? Now, I hear students all the time say, why did you cancel this course? Why do we have a new course? Why did we change the content of this course? Well, it's for your sake, not for ours. It's not because we enjoy changing things. Okay, actually, if you've ever been a faculty member, or you ever know anything about curriculum changes, it's hard to get things changed. It's hard to develop new courses. So we don't do it just because we have fun doing it. We do it because there's a reason. And I've got some quotes from some people. Preparing students to enter the MIS workforce with the tools necessary by industry is one of the most important things in curriculum development. That's by a guy named Gordon Davis. Another gentleman, Collins, said the real test of a program is whether it meets the needs of industry. And the third thing says technology changes demand not only new programs, but the constant attention and tuning of the current curriculum. If you've been around here for any period of time, you've noticed that our curriculum has probably changed more than almost anybody on campus. We've changed names of departments, we've changed names of programs, we've changed names of classes, we've redone everything. But again, it's for your sake that we can keep up with what industry wants. So that's why we do all these things to change curriculum. Back before 1987, I looked to see what had been done. And back as early as 1972, a gentleman said skills that are needed are technical in nature and include programming, systems operations, and systems analysis. So in 1972, the world then called data processing said the three most important skills we can give a student is programming skills, operational skills, and we're talking about mainframes obviously, and systems analysis. Then in 1982 came along Mr. Martin, who ranked systems development and operation skills again as the most needed. As you got to remember now, we're talking about mainframe programs that they're proprietary in nature. Each of them have to have their own operating team, their own operation functions, and they have their own operation systems. Then in 1984, Dixon came along and said, there's been some changes in the last few years. We're no longer all technical. We need people skills. Now, I know there's some CS people in here, And up until this time, basically, we were all technical. There wasn't computer science and DP, one managerial and one technical. It was basically everybody's classes were all technical. But in 1984, a guy named Dixon did some studies and said, we need to develop people skills, which include planning, end-user management, automation, and the first time we saw this word come in, which is telecommunications. People often ask me, what's the difference between a curriculum in computer science and information systems? And I tell all sorts of things, and I tell them that neither one can survive without the other. Computer science people design, they build, they develop systems, and we use them to make money. Okay? Because if it wasn't for the business application of these systems, why would they be building them? And what can we use to make money if these people weren't building the systems for us? So we both depend on each other. Starting in 1984, we saw more of a change of the curriculum between the two. Computer science stayed in a more technical aspect, and we began to be more managerial, or adding managerial skills. Mr. Cheney did a study in 1987, and he said the most needed technical skills of MIS graduates, and I use MIS, of course we've changed the name through the years, planning, simulation, statistical theory, database administration, and telecommunications. These are the things that Mr. Cheney found that industry wanted from IT graduates, whether it be CIS, CS, whatever it happened to be. And we'll see how this develops over the years. Some of these disappear. The ACM came along, the Association of Computing Machinery, took it upon themselves that says we need to develop a sample curriculum that everybody needs to study so that everybody can be on the same page. So the ACM back 20 years ago said we're going to identify 10 things that we think are important that all curriculum should cover. And so they came up with the things of computer programming, systems development, database, telecommunications, knowledge-based systems, which were DSS, decision support systems, and ES, which are expert systems, resource management and planning, architecture, which they identified as the operating systems, the study of the operating systems and the hardware, legal and security issues, concepts, and problem solving. So ACM said these are the 10 things that we identify as what curriculum should cover. Not necessarily all to the same extent, but you should have coverage of these 10 items. Now, in 1992, I collected data, did a study, and I developed several hypotheses that I wanted to check on. Some of those we're going to talk about today, and some of them I cut out because of time's sake. One thing I wanted to know is, are we teaching what industry thinks is important? Because if we say that industry should guide our curriculum, then obviously we need to be teaching what industry thinks is important. So the number one thing I said, is there a correlation between the ranked average of importance, the order of things of skills that we think are important, of MIS topics, by programs of work, POWs means programs of work, degree plans, between programs of work and industry needs? How close is our programs of work meeting what industry says we should do? Number two, I wanted to find out, what was the relationship between MIS topics and programs of work, was the relationship between MIS topics and programs of work and industries stronger than 1987? I found data that had been collected in 1987. I collected additional data in 87. And then I collected the same set of data back in 1992. And I said, well, not only do I want to know the relationship of are we meeting industry's needs in 1992, are we doing it better than we did it back in 1987? Or are we getting worse? And then the next thing, the correlation between RAI, the MIS topics, by POW, by programs of work, and academicians. In other words, what do academicians, the faculty, what do the faculty think are important? And is that reflected in the programs of work? It's amazing, but everything we think is important isn't necessarily in the degree plan. And so I said, well, the other thing I want to do is I want to survey the faculty and see if the faculty say what's important. Are they teaching what they think is important? Are they teaching what somebody else says is important? I thought that would be interesting. Number four, I said I want to know the correlation between the RAI, the topics between 1987 and 1992. So how much has the curriculum changed between 1987 and 1992? And I know most of you weren't even born then. But what I'm doing is giving us a starting point in 87, because what I'm going to do is take the same research to 1997 and then to 2006. So I wanted to see, are we have we changed? Has curriculum changed between what we thought was important in 1987 and what happened in 1992? And then I also want to see, has industry changed? What does industry want in 1987 and what do they want in 1992? So here's what I did, and I repeated this several times over the years. So the first thing I did was I said, okay, my school population is going to be all AACSB schools. At the time, there were 176 accredited schools, and now there are over 500. So I said, I'll use as my schools the 176 AACSB schools. So what I did was I collected degree plans from 1987 and 1992, and I wanted to see what was being required in the major for all the degrees across the United States in these 2 years. And then I said for industry what they think is important, I want to ask the IS major, the IT manager rather, of all the Fortune 500 companies. I actually got 115 returns, which I thought was pretty good. I had 23% return on my surveys. It took about 6 months and about 3 or 4 trials, but we finally got there. Academicians, what I said I'm going to do is I'm going to send it out to the department heads of all the departments of all these AACSB schools and have them turn it in. And now this is pretty sad that academicians only beat industry by 3% of return rate. Usually you would see academicians' return rate be double what that is at least of what industry does. But here, I guess the faculty members didn't care much more than the industry did. Or they cared the same. Okay, how am I going to do this? How am I going to compare apples with apples? Well, the first thing I said is I want to map all the courses that all the people take in their curriculum into that ACM 10 topics. So what I did was I took the course description of every course, I took the keywords of each course and fit it in and mapped it into one of those 10 areas, one of the 10 ACM areas. And then there were also skills at the ACM associated with each of these 10 areas. So what I did for the industry is I sent out all the skills and asked them how important it was. And all these skills mapped directly into the 10 categories. So I said, okay, I can map the courses into the 10 categories, I can map the skills into the 10 categories, and see how the ranks are. And then I also had special things like some people offered quarter hours, I had to transfer those into semester hours. And then also, as you know, in some degree plans it says take any 3 of the following 6, any 3 of the following 7. So without information, I had to assume that they were all taken equally. Now, that's not a true assumption because as we all know, there are some courses that will be taken more heavily. There's no way I could know exactly how many took each course. So I just assume if they said choose 3 of the following 6 courses, then each one of them was taken with an equal amount of regularity. Now, first little piece of information. In 1992, programs of work on the left, industry on the right. The most pronounced, in other words, I ranked them by credit hours, how many credit hours were required in each of these categories. In 1992, more credit hours were required in system development than any of the other 9 areas, followed by programming, database, telecom, the management of IS, knowledge-based systems, problem solving, legal and security, systems concepts, and architectures. Now, again, this has been, 14 years ago? But this is what was being emphasized in programs across the U.S. at this particular time. Now, industry said, these are what we think are important. And if you'll notice, close, we have a lot of similarities here. Industry, of course, they're still hiring technical people in 1992. We really don't care about legal security issues back in 1992. We want it up, we want it working, we don't care about how legal it is, we don't care about security. You know, we're talking about pre-internet, World Wide Web surfing and all that at the beginning of that era. Knowledge-based, ESS, ES, not that much important. Architectural systems of the old OS mainframes, not that important. So the top 4, basically system development, telecom, database, and programming, you see over here in just a little bit of a different era. So there was a lot of correlation between what we were teaching in 1992 and what industry said was important. So I don't know if you think of any surprises. For 1992, now I did put the 1987, I don't think programs of work up here, but one distinct change in 1987 was telecom was way down here. Because a lot of things happened in the internet world between 1987, or networking world between 1987 and 1992, and telecom came up. Now you're going to see telecom go another direction when we go to 2006. And this is important to you students because when you think about where are all the jobs, when we get to the 2006, you'll see which ones are does industry think are the most important, and you'll see some changes come around. Okay, now here's the boring part. statistics, right? Okay, I have rank data, and so I want to know, I have these two sets of rank. And I want to know how closely they're correlated together. At the time, I chose a statistics called Spearman's Rho. Spearman's Rho is 1 minus the sum of the differences squared. In other words, if something's ranked 2 here and it's ranked 6th over here, the difference would be 4. If something was 4 here and went up 2 here, it'd be negative 2. You take each of those numbers squared, sum them together, and divide them by the number of categories times the number of categories squared minus 1, or divided by, excuse me. And you'll come up with the number. And so, what we found was the correlation between these two gave us a row of 0.8424. Now, there's a table, and if any of you take statistics, you know people develop tables and say, okay, if you have this statistic number at this alpha level of significance or assurance, is acceptable or not. So, you go to the table, you look up 0.842 rho, and it says there is significant correlation existing at the 0.05 level. So with a 5% assurance of confidence, these are directly correlated together. So they're close. Now, the lower this number gets, for those of you who are not in statistics, the lower this number gets, the more sure we are they're closely correlated. This number here, the higher that gets, if this number is 1, it means they're exactly the same. If this number is 0, then there is no correlation whatsoever. So this is the main thing we're going to look at. If you look at the rows changing, if you see this number get larger, it means there's been less change. Okay? Now, I want to see what happened in 1992 between the programs of work and what the teachers thought, the faculty thought. So, in 1992, you're going to see it even closer. So, what faculty were doing and what faculty thought were important and what they were teaching in their curriculum was even more closely correlated. In other words, there was more of a match. And so, you look here at the Spearman's Rho, and it gave a Spearman's Rho of 0.903. Which means it was significant at 0.001, which means extremely high level of correlation. So basically, teachers were teaching what they thought were important. If they thought it was important, it was in the curriculum and that's what they were doing. Now, since the correlation with industry was less, even though it was correlated with what industry thought was important, there was a higher correlation with what faculty thought were important. Now, there's always been discussion about what should generate curriculum, who should generate curriculum changes. Should industry generate curriculum changes? Should we base our curriculum on what we find out from industry, what they want? Or should we generate it on what we know because we know better? And there's always been that argument on two sides of the house, because some people think faculty know better what we should teach, some people think industry knows better what we should teach, and I'm not here to debate that. But basically my firm thought is, if I've got you out of a class, if I've graduated you out of a program, you should be able to get a job. And they're not going to hire people based on what I think is important. They're going to hire people on what they think is important and what they need. And so I think we need to be in tune with what industry says, and we should be providing you with what will get you the best job and what you want to do. Some of the other things I looked at, I looked at industry in '87 versus the programs of work back in 1987. So again, I collected the programs of work. I went back in history and collected all the degree plans from 1987 of all the AITP schools. Somebody else had already done industry back in 1987 of the same Fortune 500 company. I found a row of 5878, which was again positive at the 0.05 level. But if we look at this correlation in '87, 0.58, and we looked at the correlation between industry and programs of work in 1992, we had a higher number. And what do we say the higher number means? It's closer. Okay? So we moved closer from what we were teaching to what industry wanted in 1987 to what we're doing in 1992. Between the programs in 1987 and 1992, the row went to 769. In other words, what program changes were made between '87 and '92? How close does what we taught in 1987 look to what we taught in 1992? It's getting a lot closer, right? Again, higher number means closer to the same. What about industry changes? How did industry change? Now, industry had a row of 6727. Now, there's still a very high number, but basically what you can look at these numbers is you can say the programs didn't change as much as what industry wanted. Does that make sense? What industry wanted in '87 versus '92 changed more than what the curriculum showed. Okay? Are we closer to industry in 1992? And so here we go. One more little statistic and then we'll be through with these guys. Calculate industry and curriculum. What we want to do is we want to see industry versus curriculum in 1987, industry versus curriculum in 1992. How close were we here and how close are we now? And I want a statistic that tells me so I can compare the two. So again, we had the row of 588 in 87. We had industry to curriculum in 92, a row of 8420. To test the equality of the two correlation coefficients, you use something called a Fisher Z transformation. There's the formula for anybody who really wants to know it. So you convert the rows to Z values, and you divide it by the known variance, and you get a resulting Z value of 2.4, which exceeded at the 0.05 alpha level, which means significantly more positive association between industry, it's supposed to be and work in 1992 than there was in 1987. So
That's 0.01 to it.
do what now?
Even still be significant 0.01. 2.4.
Yeah, so it would be a 0.01 too. So basically what we're saying is there was more association between the programs of work and what industry wanted in 1992 than there was in 1987. So we're doing better. We're getting closer. In 1997, now we're going to move up to a little more newer time frame. In 1997, ACM said we need new guidelines. The world's changed. We need to teach new and different things. Now they came up and said, here's our new 10 guidelines. We're going to have fundamentals of IS theory and practice, hardware and software, programming, networking and telecommunication, analysis and design. Here's a new guy on the screen, DBMS. They said this is significant enough it needs to be one of the 10 major functions. Personal productivity, project management, physical design and implementation. In 1997, they said these are the 10 things that are important. 2 of these should come in the core, in the business core, outside the major. The 2 things that should come outside the major is personal productivity, which is learning how to use Microsoft Office and other type of items like the internet, things of that nature, and then also fundamentals. The AITP, which accredits College of Businesses, they made the same decision, and as you know, if you've gone through the curriculum in the College of Business, the 2 core things that you have to have, it doesn't matter what you major in the College of Business, you have to have MIS 3013, which is a fundamentals class, and you have to have 1503, the tools class, or an equivalent something. So basically we teach those 2 things out of the core, and then the other 8 things should be located in the core. So I went back and did 1997. I collected all the curriculum again from 1997 from all the AACSB schools, which had increased by about double. And it was a little hard, but I fed them back into the categories I had before because ACM changed the categories, but for me to compare apples with apples, I had to use the same 10 categories. So I still use the 10 ACM categories from earlier. And so here I'll give you the same categories that we had in 1992 in order of importance from system development down to architecture. And then according to programs of work in 1997, these are the order in which we found importance placed. As you notice, what moved to number 1? Programming. Programming became more important. However, telecom also moved up the list. At this time in 1997, again, telecommunications and networking is very important. In fact, in 1997, around that era, we here at ASU, we put an emphasis in telecommunications and networking in. We added more networking classes. We emphasized networking as one of our strengths because that was one of the major deals. And that was one everybody wanted to major in because that was a hot topic at that time. Database is also necessary, and systems development fell down the loop a little. Now, legal security moved up just one little notch. Again, we're not to the year 2000 yet, and we'll see another change when we hit over past the year 2000, but legal security became a little more important. And now problem solving, I disagree with this, but I guess, problem solving is a hard thing because what classes actually teach just problem solving? Okay, it's hard to identify a curriculum course that teaches only problem solving. I mean, we teach problem solving in everything. To me, programming is problem solving. If you have to write a program to answer a question, it's a problem solving. So we teach problem solving in everything, but very few people teach problem solving as a course. Now, when you look at industry will tell you one of the most important things they want you to do is solve problems. Okay, so that's going to be higher on the list on industry than it is in academia. And just because, not that we don't think it's important, it's just that the way that I did this, because I can't sit in everybody's class and see what they teach. I simply had to go by the course description and what they required. I can't say, well, I wonder if they teach problem solving in that course. I would hope that in every programming course and everything else, they teach some type of problem solving. So these are some changes. And again, you see some minor changes, nothing very big. And so I said, how closely are they correlated? So here we go with Mr. Spearman again. We calculated a row of 0.927. Pretty high, right? With 1 being a perfect correlation. Positive correlation at 0.001, which means not many significant changes. If you look at curriculum across the United States between those 5 years, 92 to 97, people were teaching the same thing. Very little in IT or MIS or CIS or whatever we called it at that particular time. Very little change. Now you might say, well, ASU changed a lot. Well, of course, we're cutting edge. So we're not like everybody else. We lead the way, we don't follow. So we do better than most people. But anyway, very little change. Then 2006 comes along. And this is where we currently are. Now, the ACM didn't develop this curriculum, but people who were involved with the ACM and other organizations developed a sample curriculum. And I didn't bring the CS. They developed a sample CS curriculum to be followed at the undergraduate and graduate level, an IS for undergraduate and graduate. But here are the new designs that they have, or the new topics that they have. Now you'll see the first two, personal productivity and fundamentals. Again, those are to be offered to every student as the foundation, and the others are those two are the building blocks in which we build everything else. And we have a new guy in town, electronic business. Didn't exist before. As you know, between the years of 1997 and the year 2006, the internet really changed our lives, right? And now look at all the classes that are simply on B2B, B2C, C2C business. Okay, web pages, web commerce, e-commerce. Those are all the hot topics. So they just said, that is one of our top objectives now, is to teach electronic business systems. We still have IS theory and practice. Still hardware and software is out there. Programming is out there. Networks and telecommunications is out there. Analysis and design. Database management systems. Now here's a new one they put added. Physical design in emerging environments. What's an example of this? Wireless. The design of wireless. What's another? Data capture. Okay? Physically setting it up where you can capture the data and process the data better and faster and more efficient. Which, as we all know, we have the nation's experts, Dr. Moini, here on data capture. So we're very fortunate to have the Sizzler here as one of the new important things there. Physical design in emergency environments. And then look at this last guy. Project management. One of the things we were lacking, in my opinion, through all these years was a course that brought everything together and had you do an overall case. A capstone course or capstone case or something of that nature. Dr. Ruby, Paula Ruby, led the way in that, developed a project management course, teaches that each semester. We require that now in the core. And so this helps you bring some of the things you've learned into a case-type environment and project-type environment. Because one of the things businesses were saying was, well, they know all the technical tools, but they don't actually know how to form a committee, take a project, start it, and get it to completion and finish, get the bottom line, turn the project in. So project management became important. Now, data collection in 2006. Yeah.
Security was not there.
Security is not there. Security is there built into the same one, emerging environments. Because what they want is, they said in all these, and also in electronic business, because in electronic business you have the need for security, and in all the new emerging technologies, data capture and all those, they have security. They put it inside other items. In fact, if you go look at the plan, even though they've only got 10 items, they got like 120 objectives. And security is listed several times under different, it's not its own. I don't know why they didn't make IT security its own, but it's there listed in several of the others. Okay, so in 2006, there are now 586 AACSB schools. I collected, or thanks to Heather Tucker, my graduate assistant, she collected all the degree plans from all 586. We categorized them, put them into topics, did the quarter hour, semester hour, choose from the list. We did all that. We now got it in a nice little database sitting on my desk waiting for me not to be busy with something else. And traveling, but it's sitting there. I've done some things with it, but I haven't done everything I want to do. Other things I want to do, and obviously 2006 is running to a close, but some of the other things I want to do in 2007 so that I have an industry comparison. I want to go back to industry, and I want to find out what industry wants in 2006, 2007. I definitely want to go back to the Fortune 500 companies so that I can do a longitudinal study and see how things have changed from 1987 to today. But also, especially for our sake, what I would like to do is I'd like to see a study of our hires, people who hire our students in the local area and the regional area, and also what about smaller IT companies? Because our graduates don't necessarily go to work for IBM or Hewlett Packard or those type places. What about these smaller IT companies? So I want to find out what their needs are, both small across the country and also regional local companies, and also maybe what the faculty think are important. So I have the data for the curriculum. I do not have the data yet for the industry, but working with some other people around and getting the data in, I want to get that done sometime before next summer. But I went ahead for this presentation and pulled up some things. Some preliminary findings. Now, these are from 10 to 1 back in 1997. Is that my bell that I'm finished? I only have about 5 more minutes, I promise. Okay, from 2006, let's look and see what they are listed from 10 to 1. First of all, number 10, as expected, OS architectures, mainframe operating systems and everything is still last. Okay? Now we're talking about on our side of the house. There's a whole different set for CS because in their world, mainframe sales is actually going up. Okay? People are going back to mainframes. We still need mainframes. We still need operating systems for mainframes. But it's basically been seen more in the computer science side, on their side of the house, than it has been in our side of the house. Next is systems concepts. IS concepts is still not as important. These are foundation concepts. This would be the same thing as your foundations course. And again, in the core, we wouldn't have many concepts courses. We expect people to have that coming in. People who come into IS programs have a concept of IS and know what the foundation is most of the time. And still, problem solving. And again, I don't think it's because it's not important. I think that it's hard to develop a course just in problem solving. I had one course in my whole life at UT, in Texas at school. I had one course that was about problem solving. The only one they offered. Probably one of the funnest classes I ever took. That's one of those where you come in and they say, okay, there's 3 white hats and 3 black hats. Everybody's got a blindfold on, and they take their hats off, switch one to the right. What color hat are they wearing now? So you sit there and try to figure out. It's all logic questions and word problems and trying to figure out how to solve those scenarios. Okay, next. Uh-oh. My favorite area. Look what's happened. Telecom fell from 2 to number 6. What does that tell you? And if you've been a recent graduate in the last 2 or 3 years, you know this. If you majored in telecom and took nothing but telecom and nothing else, you will have trouble finding a job. Why? Because networking people can cover a whole lot of area. They don't need 1 for every 5 people or 1 for every 10 people. We do need more programmers. Okay? So if you're looking at CS, CIS, anything, telecom's still important. But don't think that it's going to be the easiest job out there to find because there's fewer of them as far as the population is concerned. So telecom fell. I really hate that too. Of course, I hate that Windows came out with NT. I wish we were still on Novell. I don't get my way. Knowledge-based systems. The most place you hear about DSS and expert systems is graduate programs. You go to graduate school, you go to research institutions, you hear a lot about it. But as far as undergraduate work, you don't see much talk at your normal institutions in decision support systems and expert systems. I mean, total classes just don't know. But it's still in the middle. And I kind of hated that it actually beat out telecom, but it did. So as you'll notice, there's a couple of these guys that have moved up. Like I haven't got to legal security yet. Oh, there it is.